Okay, so today we're going to be talking about Module 1.2, which is called modeling quantities. But what we're going to be specifically working with is we're going to be working with ratios and proportions, how to solve those, how to set those up, and also dabble into a little bit of unit conversion today. Alright, so what you're going to be doing specifically today is you're going to be using ratios and proportions to convert units and solve simple proportions. So the idea is I'll show you how to set up some of these ratios, how to set up a proportion, and then we're going to progress with them the same way that we do with our one-step equations. They just look a little bit different, and there are some other skills and other ways that we can go about this that we will talk specifically about in class. Alright. And so just like always, what we need to make sure that we're doing is that we're at least nailing down some of the vocab. So what we're going to look at specifically are ratios and proportions, their definitions, and some of the examples. So a ratio, as you can see, is a comparison of two numbers by division. So no matter how this kind of gets set up, a ratio takes two different things, two different numbers, compares them with division. So for example, if you say that you hike 2 miles for every 4 hours that you're out there, that is considered a ratio. Now sometimes they don't even have to be anything. You could have 1/3, you could have 5/7, you could even flip this around and say 10 divided by 3. But the idea is that these are ratios. Now proportion, on the other hand, says that two ratios are actually equal to each other, and we do that by setting up an equation. So a proportion is just another specific way that we talk about an equation. Now this is no different than comparing two fractions and saying that they are the same. So if I walk 2 miles for every 4 hours that I have, that is the same as me walking 4 miles for every 8 hours. So it's just showing that two things are exactly the same, because if I was to reduce both of these, they would have the exact same value. And that's what a proportion does. But we are able to talk about proportions as a way to solve for a particular thing. So if I was to tell you that my pace is 2 miles for every 4 hours, then I can take that and say, well, how many miles am I going to walk after this number of hours? Or if I walk for this number of hours, how many miles am I going to be able to walk? And I'll show you examples of those here in a second. But the idea is that a ratio is just a fraction. It's comparing two different things. A proportion is saying that two ratios are exactly equal to each other using an equation. And so we have an example here. So the way that we use ratios to create proportion is to use cues for our assistants. So if you look here, you have a totem pole that is standing next to, or a person that is standing next to a totem pole, and the idea behind this is that you have a shadow. So you have the shadow of the totem pole and you have the shadow of the person. Now the sun is in the exact same spot, so we can say that these shadows are proportional to each other, because it shouldn't matter the height of the object. It's going to cast a similar or a proportional type of shadow. And so we can use these two different things. So the way that we can set up a ratio, or the way that we can set up, or at least start to set up a proportion, is we can talk about the actual height. So you notice what I'm doing here is I'm setting up kind of a particular scenario that I'm going to compare everything. So the actual height, and I'm going to compare that, the shadow, to the shadow's length. And so the idea is that I can compare these two things, whether it's the totem pole or the person standing next to it or anything else in that vicinity. And so for example, the totem has a ratio of its actual height to its shadow length of 90 feet to 45 feet. So we're making this comparison of two different things. Now they refer to two different things, so that's the idea. And then the person, their ratio is 6 feet for their actual height, and then their shadow length is X number of feet. So it doesn't matter if it's a number, if it's a variable, we can use these two things to talk about how these are ratios and how they're comparing. But the most important part is that when we're setting up ratios for multiple things, we need to make sure that we stay consistent. So if I'm going to say this is my ratio, I need to make sure that I keep that ratio the same with everything that I'm doing. I can't flip-flop it for a different item. Even though it's still okay to do that, I want to make sure that everything that I have stays consistent. If I wanted to flip that from the start and kind of take these two and reverse them, where it would be the shadow length divided by the actual height, you could do that as well. But the idea is you would have to do that for everything that you are making a ratio for. So, how do we use these ratios? How does this help us find out what the length of the shadow of this person is? And so we can say that this proportion, this kind of factor, is the same no matter whether it's a totem pole or it's a person. And so we can say the actual, yep, the actual over the shadow, and kind of shorthand is this. And so we can start to compare these two things to each other. So if we go to the totem is going to equal the person. And so that ratio of the actual height versus the shadow is going to be the same for both of these things. So the way that you set this up is you have a ratio on one side and a ratio on the other. So we have 90 divided by 45, that's the actual to the shadow, equals the actual to the shadow, and in this case is x. So this is right here in itself a proportion. So now what we can do with things like this and what we can kind of start to create is we can start these kind of one-step equations to be able to solve for certain things, or there's other ways that we can do this, and we'll highlight these as we move forward. Alright, so let's look at another example where we can start to create different ratios. So we have two different scenarios here. First of all, we have a man that has walked 3 miles in 37 minutes, and we want to know how long it would take for this same person to walk 5 miles at the current speed that he's setting. So what we want to do is we want to set up our ratios for each individual situation that we have, but what we need to make sure is that we keep it consistent. We want to make sure that our ratio has the same form. So what we're going to make sure that we do is that we're going to take the minutes on the top that it takes to walk, and then we're going to have the miles or the distance on the bottom. So that is going to be the general consensus of the way that we're going to set up our ratio. So we're going to take the minutes divided by the miles and compare that to how long it would take to walk in 5 miles. And so the way that we're going to do this is we're going to set up a proportion. So we're going to take the one thing that we do know, 3 miles in 37 minutes, and say that that is going to give us 37 divided by 3. That needs to be the same as, we're going to say how long would it take. So the idea is that that is our variable, that is our x, that is what is missing. So we're going to say x divided by 5 miles. Now if you look at this and you look at this very carefully, you can see that we are dividing by x. And so in a sense, this being our proportion, is we're going to solve this the same as we do a one-step equation. Now the idea behind here is that most of the time all that you're going to do is you're just going to have to multiply because you are dividing. That's the whole nature of being a ratio. But the idea is that we can solve this very quickly the same way that we do this. So if I'm dividing x by 5, I need to clear that variable. So I'm going to do multiply by 5, and then I'm going to multiply by 5 over here. Now for some of you this might be a little bit difficult. So we have 37 divided by 3 times by 5. But for something like this, we just want to know how long it would take in terms of minutes. And so what we can do is we can just go ahead and grab a calculator, multiply 37 times 5, and then divide it by 3, or however you want to work that out. That is going to be equal to x. And so x in this particular case ends up being roughly 61.7 minutes. And we'll round that to the nearest tenth just for the sake of minutes. So the idea is that we can kind of use our one-step equations, we can use this idea of ratios and fractions to be able to help us set up and solve proportions. So let's look at another one. So if you read the problem, it says a scale model of a human heart is 196 inches long. The scale is 32 to 1. And so we want to know how many inches long is the actual heart. So the idea is that we need to set up some kind of ratio. We need to set up some kind of situation to say that we have a scale model versus our actual. So remember our steps. We need to set up a ratio. We need to be consistent. So we need to make sure that we have a plan. So the way that I can do this is I can say, well, we'll go with the actual divided by the scale. And so that will be the setup. So if we look at the scale model of a human heart is 196, that means we don't know what the actual is. And so we would say that that's x divided by 196. So that is the actual human heart versus the scale model of a human heart. And so the scale is 32 to 1. And so the idea behind that is that we're going to set that up the same way, is that for every 32 we're going to be given 1. And so the way that we would set this up is that the actual is 1 for every 32. And so the idea is that it says the scale is 32. So that helps us decide what it is that we're going to set up and how our fraction is going to be created. So it kind of gives us that information. But notice what we did is we kept everything the same. So in order for us to do this, we're going to solve as a one step. Yep. And so what we're going to end up doing is we're going to see that we have x being divided by 196. And as we learned, in order to get rid of division, we have to multiply. So we're going to multiply both sides by 196 times 196. And so what we end up having is we can go ahead, reach for that calculator in a situation like this, and we can say that 196 divided by 32 gives us x equaling 6.13 inches. And so the idea there is that we can still calculate what these are by setting up our fractions, setting up our ratios, and then solving like a one step. Okay, so it's just important to remember that ratios are just fractions, so you have x over y, and that can be whatever you want to. But a proportion is an a over b equal to, let's say, a x over y, where those things are going to always be the same. So in effect, a is always going to be what x is, and b is always going to be what y is. Now they might not look exactly the same, but they will eventually simplify. But ratios are just a single. Proportions is when we say that both of these are equal. So that's going to do it for this video. Now keep in mind there are a couple of examples that we skipped over, but we'll get back to those when we have class again. And that's going to do it for today.